Hello, here's the question number 28, which reads, in the circuit shown, this is a circuit, a parallel combination of a coil of inductance L and a resistance R can be connected across a battery of electromotive force E internal resistance R through a switch. Find total heat dissipated in resistance R after the switch is closed. So this switch was closed, so there will be current going through this and this inductor, then there will be settlement, and we need to find the total current passing, total heat dissipated by this resistance. Now we can have this circuit at any time t. So this is R, this is L, this is battery, and then this internal resistance. Let's say I current goes through the battery, I1 through the resistance, I2 through the L. We can use Kirchhoff's laws, Kirchhoff's voltage law. We'll say I1 R plus I small r is equal to E. So that's for this loop. And here you will find L di2 by dt is equal to I1R, L di by dt is equal to I1R, so the second KVL. At this junction, we can apply this Kirchhoff's current law, which says I is equal to I1 plus I2, as simple as anything. Now, we can use this I in this expression, so this will become I1R is plus I1 plus I2 small r is equal to E. From here, we can simplify for I2 turn out to be E minus I1 within bracket R plus small r divided by small r. So that can be easily understood by collecting I1 terms together, shifting this side and dividing by small r. So that's I2. Now we can differentiate this I2 because we require di2 by dt. So di2 by dt will become E, differentiation of E will become 0. So this minus will be outside, and there will be capital R plus small r divided by small r. So that this, and differentiation of I1 with respect to time. So that is di1 by dt. So this will be L di2 by dt. Now we know as per this relation, this is also equal to I1R. So di2 by dt can be calculated from here, which is I1R by L. So that can be written over here. Now this could be further simplified. So it's like di1 divided by I1 is equal to minus small r capital R divided by L small r plus capital R into dt. Integration from 0 to t, and then this will have an initial, let's say initial current was I naught in the initial value of I1 was I naught to I1. So we are going to integrate in this manner. Now this will turn out to be ln I1 by I naught, and this will be coming as a t, so minus small r capital R t divided by L r plus r. From here you will find I1 as I naught e raised to power this expression. Now how much this I naught will be, that means the initial current through this resistance. Now you know, as soon as this switch was closed, then you'll find this inductor will not allow any current through this, because we know these inductors do not allow sudden change in the current. So the entire current will run through this resistor, and we will have this circuit only. And from here, this current I naught can be written as E divided by capital R plus small r. So that's I naught expression. Now we need to find the total heat dissipated in R. So that will be capital H, let's say heat is equal to I1 square R dt. Now this will be like I1 square, which is I naught square, and the square of this will bring 2 over there, and R dt. So we can take this I naught square R outside, and we can go for integration. Exponential will have the same integration. However, the coefficient of t will be divided. So that is minus 2 small r capital R divided by L capital R plus small r within bracket. Now limits will go from 0 to infinity. This minus will absorb this thing. So when we put the infinity over here, so that will become e raised power minus infinity is 0. When we place 0 over here, so e raised power 0 as 1, so that will like 0 minus 1, and there's minus outside. They can be further settled, are getting cancelled out. This comes outside, so it becomes I naught square L within bracket capital R plus small r divided by twice r. Now this minus and this minus will settle down, and now we can substitute this I naught, which is E divided by R plus R. So it's like E divided by R plus R square into L R plus R divided by 2R. 1 R plus R will get cancelled out, so expression turn out to be E square L divided by R plus R into 2R, which could be rewritten like this: H is equal to E square L divided by twice R within bracket R plus R. So this is the heat generated by this resistor after a switch was closed until the long time. So that's our final response. Thank you.